Welcome to my presentation. In this presentation, let us look at the procedure to solve system of linear equations using Cramer's rule. Okay, so Cramer's rule is a formula that uses determinants to solve system of linear equations in n variables. So let's say we have a system of linear equations of this type: a11 x1 plus a12 x2 is equal to b1. Let's say this is equation number 1, and equation number 2 is a21 x1 plus a22 x2 is equal to b2. Let's call this as equation number 2. Okay, these are system of linear equations in two variables, x1 and x2. We can write the augmented matrix for this particular system of linear equations, and then to write it as an augmented matrix, we can pick the coefficients of the variables x1 and x2 and then write them out in a matrix format in this manner: a11, a12, and then b1 is the constant term, and then a21, a22, and then b2, and then we can put them in open close brackets of that nature, and then we can put a dividing line between the constant numbers, constant terms, like that, and therefore a11, a12, a21, a22 can be thought of as the coefficient matrix, because those are the coefficients for the variables x1 and x2 in equations 1 and 2. And then Cramer's rule is telling us an easy way to solve for the variables x1 and x2. The way to do that is as follows. We'll call that as step 2. I'm explaining the procedure here. Once we finish explaining the procedure, we will solve some simple example problems. In step 2, if we want to find the value of the variable x1, the way to do that is as follows. We're going to find the determinant x1 for x1 divided by the determinant of the original matrix, and that is saying like this. So in here we will be, let me do this. In here we will be writing the determinant in the numerator, and we will be writing a determinant in the denominator. In the numerator, the way we want to write this one is as follows. We're going to replace the coefficients of x1 and x2, x1 in the first column, and then replace it by the constant terms. The constant terms we have is b1 and b2, isn't it? We'll write b1 and b2 for a11 and a21 for the first column. We'll replace a11, a12 by the constant terms, which is b1 and b2, and then keep the second column the same, a12, a22. We'll keep those elements the same, and in the denominator, that determinant will be the coefficient matrix itself. We are not going to change that. We're not going to change anything. So the coefficient terms of the variables are a11, a12, a21, a22. So by replacing the first column by the constant elements, we should be able to find the value of x1, and that is what the Cramer's rule is telling us. And to be able to get the value of x2, we do a similar type of thing. x2, we can write this as dx2, the determinant of x2 divided by the determinant of the coefficient matrix. The way we can achieve that is as follows. In the numerator, we're going to write the determinant, and this time we're going to replace the coefficients of x2, which is a12, a22, by the constant terms. So We'll write the first column as is. The first column is A11, A21, and then this time we're going to replace the second column by the constant terms, which is going to be B1 and B2, and then the denominator is going to be the same. The denominator matrix determinant is going to be the same. Let me get that with this black ink here, which is A11, A12, A21, and then A22, the determinant of the coefficient matrix. And then now it is just a matter of expanding these and then finding the determinants. We know how to find the determinants of a 2 by 2 matrix. We know how to find the determinants of a 3 by 3 matrix. So Cramer's rule gives us an opportunity to solve system of linear equations. In my next presentation, we shall see how to go about solving system of linear equations using Cramer's rule.